Hello. Today we're talking about section 4.3, which is writing equations in point-slope form. This is linear equations, continuation of our work with linear equations. And you may recall that we have a form for linear equations, y equals mx plus b, where m is the slope of the line, and b is the y-intercept. That is the place on the y-axis where the line crosses, the y-axis. All right, this is slope-intercept form. Slope-intercept form. And that's because it has the slope and the y-intercept in it. Now, there are two other forms for linear equations. One of them is called point-slope form. And that is y minus y1 equals m, the slope, times x minus x1. M is still the slope. Y1 and x1 represent the values of a point on the line. So it would be a point x1, comma, y1. And notice that the negative sign is built into the equation on both sides. Now let's take a look at how we use that. Let's say, for starters, let's make it very easy. Let's say, let me rewrite this, y minus y1 equals m times x minus x1. All right. Let's say, for starters, that we are given a slope of 1/2, and we're given a point of 4, -5 that is on the line. To write the equation in point-slope form, we're going to do this. We put 1/2, which is the slope, in here in place of m. And we put this point 4, 5. Remember, this is x and this is y. So here's what I'm going to do. I'm going to say y minus, now the y value is -5. This minus stays. -5 equals 1/2, the slope, times x minus the x value of 4. Okay? I'm going to leave that there so you can study that for a minute. While we do that, minus minus is a plus. So this becomes y plus 5 equals 1/2 times x minus 4. This is point-slope form. Students are often tempted to use the distributive property and multiply the 1/2 times these two values. Don't do that at this point, because that's the form you want it in, right there. Let's do another one, and I'm going to make it a little bit harder this time because I'm not going to give you the slope. So in this case, we're going to have, let's see, let me write them over here. We're going to have a point 3,7 and another point 2,10. Okay? So, I'm going to find the slope 10 minus 7 over 2 minus 3. All right, 10 minus 7 is 3, 2 minus 3 is -1, so we have a slope of -3. That is going to go right there in place of m. So, I have a -3 here. Now, I can take either one of these 2 points and put them into this equation for x1 and y1. So let's do this one first. It's going to be y minus 7 equals -3 times x minus 3. That is a correct equation for the line that goes through these 2 points in point-slope form. However, there's another correct answer, and that is if I take this point, and it is y minus 10 equals -3 times x minus 2. Now, how can there be two different equations that represent the same line? Well, let's take each of these and turn them into slope-intercept form. So the first one I'm going to take over here, and the first thing I'm going to do is now I'm going to multiply the negative 3. I'm going to distribute it, because now I want to change the form. So this becomes y minus 7 equals negative 3x plus 9. So this distributes to here and here. Plus 7 on both sides gives me y equals negative 3x plus 16. Okay, so this is the slope-intercept form of this equation that was originally in point-slope form. I changed the form. Now let's see what happens if I take this one and change its form into slope-intercept form. So I get y minus 10 equals negative 3x plus 6. Okay, I'm going to add 10 to both sides, and I get y equals negative 3x plus 16. Those two are identical. So the fact that we had two different equations here doesn't mean they represented different lines, because they came out to be the same line. They were just using different points. The first one used the 0.37, and the second one used the 0.210. One more thing I want to make sure you're clear on here, and that is with point-slope form, y minus y1 equals m times x minus x1. Let's use a point that is, let's say, negative 5, negative 8, and negative 2, 12. Okay? So here we're going to find the slope. 12 minus negative 8 is 12 plus 8, which is 20. Negative 2 plus 5 is 3. So 20 over 3 is our slope. Take either of these 2 points. I'm going to take the first one. Y minus negative 8 is equal to 20/3 times x minus negative 5. Like that. Okay? This becomes a plus. Y plus 8 equals 20/3 times x plus 5. What I'm demonstrating here is that the form calls for a negative here and both places. So actually what this means is y minus negative 8 equals 20/3 times x minus negative 5, which means the point we plugged in is negative 5, negative 8, not positive 5, positive 8. Okay? I hope that's clear. Look at it, look at the video again if you need some further explanation of that. That is point-slope form. You can graph an equation directly from point-slope form, but you don't know the y-intercept. So if you need to know the y-intercept, put it into slope-intercept form. You would graph it, of course, by taking a point. In this case, it would be negative 5, negative 8. And then this would be hard to do because the slope is 20/3, but you would actually, you would do negative 5, negative 8. So negative 5, negative 8 would be right here. And then you would go up 20 and over 3. I don't think I can do that. Let's see. Down 3, up 3. There's 5. Maybe I can. 10, 15, 20. Yes, I can, and over 3. Okay, so the line would look like that. And the important thing to note here is you can graph from this form, from point-slope form, because you have a point on the line and you have the slope. You don't have the y-intercept, but in this case, you don't need it. Okay, that's enough on this topic. I will see you next time.